Here are some basics on torque. All right, we have this. This is as fundamental as it gets. You have an arm from a center point or a fulcrum, then you have a force that's impacting this arm, and in this case, F1 and F2 would have the same impact because they're both going in the same direction. They're both pushing this arm in the same direction. And also important is the distance D from the force down to your center or your pivot point or your fulcrum. And torque is going to be equal to the force times the distance. It's going to be in Newton meters. And important here is that this distance D is the perpendicular distance from the fulcrum or the center. And we'll get more into the perpendicularity of this on the next page. Okay. Now here, excuse me, we've changed things up just a little bit. You'll see that this force is actually coming up at an angle. And I've drawn it here so that the force is going up at this angle theta. It could just as easily be coming from down here and pointing up. So it doesn't matter regarding this point, it doesn't matter if it's up here pointing up or from below pointing up. Same effect. Okay, and what I was talking about earlier is we are concerned with the force that is perpendicular to the lever or the moment arm. Okay, so here's your lever, and sometimes it's referred to as a moment arm. And so we want the perpendicular distance, and we're also talking about this force here. This force, the force that is perpendicular to this lever or this moment arm, not this force. And also the force in the y direction here is going to be pulling away from the center point or this fulcrum, and so it doesn't do any work. Torque is talking about going around, the force going around in a circle. It can be going clockwise or counterclockwise, doesn't matter. Note that Fy, okay, I just went over that. Note that Fy is doing no work because it is simply pulling away, so it's not going to move this arm to the left or to the right. It's just pulling away from the center point. Okay, torque is concerned with a turning or twisting motion in a circular direction, just as we said, not away from the center or the fulcrum. Okay, and here the force that we are concerned about, this Fx or F sub x equals this force here times the cosine of this theta. And on tests, they may give you other angles that you have to figure out this theta. But this theta is the important. This particular angle here is important because you're trying to get the perpendicular element component of this force that's pushing this arm. And again, torque equals F sub x times the distance. And again, there's your distance there, the perpendicular distance. Okay, now here again, and this is just carrying it further. And I drew this picture to emphasize. Bring my other one down here. Okay, here, as I mentioned earlier, right here, this force is on top of this point, pushing upward like that, and here it's coming from underneath. But it doesn't matter; they are both going in that direction. As long as the direction is the same, it doesn't matter where you put this arrow. Okay, as long as it's going through that point, and that's the main purpose of this particular page. Pardon my shuffling the pages here. I don't have anything to hold the camera. Okay, so here, the arm that we're looking at has its full distance is D1, And this force is coming here at this point here, and its distance to the center here, or the fulcrum, is d2. And what I want to point out here, or ask you, which distance do you think we'll use as the moment arm, the distance, the perpendicular distance? Will it be d1 or will it be d2? If you said d2, you are correct. We want the distance, the perpendicular distance from the force where it contacts this arm here to the center. Okay, and this, and I've given some different thetas here. So the theta up here is theta 1, and this is theta 2. So I actually took the angle off the bar here, comparing it to the force. And so we want this f sub x, and f sub x in this case is equal to f sine theta 1. So I don't want you to just think that it could be, that it's got to be cosine, because we're looking for the perpendicular component here. So we want fx. Again, fy is doing no torque work on this arm. So f sub x could be the force, this force here, the black force here, times the sine of theta 1, or it could be the force times sine, and then 90 minus theta 2, or it could be force times cosine theta 2, or it could be the force times cosine 90 minus theta 1. If you have any questions about that, you'll have to talk to me later. But each of these will give you that same f sub x component. And again, torque is equal to f sub x times the distance 2, and that's the distance that we care about. It's the distance from the point of contact to the center. Okay, here's a little bit of an application here. Okay, I've mentioned a fulcrum. This is an example of a fulcrum. And you may have seen something similar to this on a seesaw. And in the case of a seesaw, both ends are equidistant from the fulcrum. But in this case, they're not. But I wanted to let you take a look at this. Okay, so this is area, point of interest A, point of interest B. And on point of interest A, the torque around A, and the torque is the circular motion going around the top of this fulcrum, where this board or line is on the pivot point there at the top. So torque A is going to be, now here's the weight of the box, okay, is mg, but the force, the perpendicular force, is what we're concerned about, and that's what's coming. That's a 90-degree angle from this line here. Okay, so this is theta 3 here, and if you do the geometry on this, you'll find that this, let me point it with a pen here, this angle here is also theta 3. Okay, so the angle that you have for this incline is also the angle that exists between the perpendicular force and mg, or the weight of the box. Okay, so again, this torque is going to be the perpendicular force times this distance 2. Notice that this distance 2 goes to the center of the mass, or that box there. So that's important, or the center of gravity, if you will. Okay, so that's the torque around A. And then I've also written out the equation for the perpendicular force is equal to the weight of the box, mg, times the cosine of theta sub 3, right there. So there, that's the equation for your perpendicular force there. Now, these T sub B's are not necessarily all equal to each other, but they're the torques around the point B, and I wanted to show you the different forms that this can take. So here's the point B that we're concerned about. So here's a torque created by force sub 1 there, and it has its angle of interest here is theta 2, and the angle here is theta 1. But for force 1, we're going to look at theta 2, and so here is the torque created by that. It's going to be F1 times cosine of theta 2, because that gives me my perpendicular component. That's all I care about with torques and moment arms. It's that perpendicular force. And at times distance d1. which is that the distance from point B to the fulcrum. Okay, and then for this other one, for force number 2, it's already perpendicular, and I probably should indicate that better by showing the perpendicular sign. Okay, my bad. Okay, so force 2 is already perpendicular, so the whole force can be used, so we don't have to convert anything. And so the torque for that around B is going to be force number 2 times that distance 1. Okay, and then this third force here, it's working around theta 1. And so here's again the torque around that point B with regard to force number 3 is going to be force 3 times cosine theta 1 times distance 1. So we want the perpendicular force pushing down this arm. So that's going to be the cosine of that force there. So that'll give us a perpendicular force times d1. And so that's how you get the torque around B with regard to force sub 3. I hope this is helpful. And again, here the parallel force does no torquing on here. It doesn't do any work there, so to speak. Okay, and I'm showing this to signify that you can take most any shape that you want to. And as far as figuring out torques, the problem is going to show you a point A or a point B or a point C, what have you. They're going to show you a force with an angle on it. It could be like that, it could be like that, or it could be like that. And because if they show the angle up here, it's still, as long as that force is along that line, you can take the angle anywhere there. And so again, you're going to be looking for the perpendicular force component here and here to find the torque that it is on this mass or this shape. And I believe that's is that the last slide? It is. Okay, hope this is helpful to you. And again, this is just basics about torque. It doesn't get into all the nitty-gritty, but hopefully this will get you off to a good start.